Welcome to Solid Edge Gear Design. In this video you will learn how to use the Solid Edge Gear Designer as a method to provide gear designs that have gears that have been tested and optimized for motion. Once the gears have been created, then motion can be added by using motors. In order to create the gears, we use a standard workflow. We identify what type of gears we wish to use. We brainstorm, we find out which gear ratios. If we want to do power, we want to increase speed. Then we look at possible solutions. We gather the information, combine the data, and then we use the gear designer that's built into Solid Edge to follow a sequence. So we start an assembly. The assembly will be in the units of measure that we wish. We can then go in and run the gear designer. The process for gear design, what we would do is we would go in after we start the assembly, we select the gear designer icon for spur gear. Now the spur gears will be created in standard forms, the tooth forms following standards with diametral pitches. When the dialog comes up, we fill in the pattern for the parameters that we wish to obtain in our results. Using the standard gear nomenclature, we can then go in and provide information that would be needed in order to optimize our gear system. We can begin by going in and starting an assembly. We need to save the assembly in order to create the gear system. Once we create the assembly, we can put it into a folder and organize the parts of the assembly that will be the pinion and the gear. So we give the assembly a name in a particular directory. We can then go back and we can now use the gear designer by selecting the spur gear icon. We go in, and one of the things that we want to change is the gear ratio. The gear ratio will allow the output to change from one gear to the pinion. We can then go in and put the thickness of the gear, the mounting hole of the gear. This will provide various parameters that the designer requires in order to provide strength. Once the parameters are put in, the gear system center distance is evaluated and placed in as well. Now we can execute the gear system from the gear designer, and it will evaluate the validation of the parameters to see if it passes or fails standard strength test and safety. Now it will generate the gears and the pinions in separate files, and those files will be converged into an assembly with gear relationships. It also creates a mid-surface at the pitch diameter, which is the center line of each gear tooth, and this is where each gear meshes against each other tangentially. Once these gears are created, a gear relationship can be seen. The gear relationships are automatically created in the assembly. Now that the assembly exists, a motor can be placed in order to find out clearance studies and motion studies for the gears. If we were to use the machinery handbook, we would go in, We would look up information in the index. We would then do the calculations by hand using a variety of formulas. These formulas are standard ways that allow designers to provide the proper gear form, tooth form. In Solid Edge, the gear designer provides us with the shortcut in design. We can then go to the design once it is created, and we can edit it in the gear designer. We can also edit the components for each of the gears in their own file by opening with Solid Edge Open File command. So what this does is allows us to make changes to a specific gear, adding a hub or keyway, the way that the gears will mount onto the shaft. This video has been produced by Patrick Turcotte. Thank you. This concludes this session.